have the equation f of x is equal to 1 minus 1 over x minus 2 squared. And I want to know what the domain of this function is. So the domain, again, is all real numbers except for the following. When we divide a number by 0, or we get the square root of some negative number. So here we don't have to worry about getting the square root of a negative number, but we do have to worry about getting a 0 in the denominator. And the only number that would allow that to happen is positive 2. All other numbers work. Put in 0, we get some number that's defined. We get any other number, it'll be defined. So our domain is every number except for 2. So our domain would be negative infinity to 2 and 2 to positive infinity. Let's do another one. Let's say I have f of x is equal to x over x squared plus 1. So here we have a situation where we might have to worry about a 0 being the denominator. But if we look and say, what x value can I put in here that will cause this to be 0? We can think 0, no, we would get 1 in the denominator. And if we go higher, we're going to get positive numbers. But also, if we go lower, we're going to get positive numbers. Because if we put in 1, we're going to get 1. If we put in minus 1, we're going to get 1. So we can see that there's actually no way of making x be a negative number to subtract 1 out. Next, x can't even be a negative number because it's squared. So there is no number that I can put in for x that will cause this to be 0. Try thinking of any. Any negative number I put in here is going to be a positive number. And I'm going to need a number to be negative 1. There's no way I can make x squared be negative 1. It's impossible. So the domain is all real numbers. Or negative infinity to positive infinity. Let's do another one. Let's say I have f of x is equal to the square root of about 5 minus x. So here we have a situation where we could possibly have a negative number in a radical. So now we have to think of what x terms are going to give us a negative square root. So the way we can get a negative square root here is if we have numbers that are greater than 5. As soon as x becomes bigger than 5, this is going to be negative because we're subtracting x from 5. So if we go 4, that'll be the square root of 1. But as soon as we get to 5, we get 0. But as the second we get bigger than 5, it's going to be negative. Even if it's 5.0001, it's going to be minus 0.00001, or 9. So we have to exclude those numbers. But if we go the other way, if we go towards negative infinity, a minus is a positive. So if I had minus 1, it would be 5 plus 1. So that would be 6. So we cannot get bigger than 5. So all of the numbers that are smaller than 5 are included. But 5 is included because it would get a 0. But as soon as we get larger than 5, as soon as x is greater than 5, then we get a non-real answer. So in order to write that, we include negative infinity, because like I said, when we go to negative infinity, this is going to become a positive sign. So negative infinity to 5. And we include 5 because if we put in 5, we get a 0. If we put in 6, we're going to get minus 1. So that's where that stops. So I think I'll do one more. Let me box it. Be consistent about it. So that's our domain, negative infinity to 5. We'll do one more. We'll do, how about f of x is equal to the square root of 2 over x minus 1. So in this problem we have a situation where both may occur. We can have a 0 in the denominator and we can have a negative under a radical. So first let's do the 0 because that's generally easier. The only number that can give us a 0 here, a 0, is 1. So 1 is not included in our domain. So let's write that over here. 1 cannot be included in the domain. And now we need to figure out what x values would cause this to be negative. So here we're having 2 over x minus 1. So what's going to make this fraction a negative is if x becomes smaller and smaller. So if we have x minus 1, that gives us 0. But as soon as we get smaller than 0, then we're going to have a negative fraction. So if I put 0 in, that's going to give us minus 1, and 2 divided by minus 1 is minus 2. So we can't have that. So 1 is also, it also just happens to be where we would all have a negative number. So if we had 1/2, let's say we put in 0.5 for x, then we'd have negative 0.5 divided by 2, which would be minus 4. So our answers for the negative are x cannot, if x is less than 1, then it'll be negative. So our domain is going to include 1 to positive infinity, and 1 is not included. We can have larger numbers. We can put in 11, and we'll get 2 divided by 10, which is 1/5. And that's fine. But again, as soon as we start getting smaller x's, as soon as we go below 0, so if we put in 1, that's going to give us a 0 in the denominator. But besides that being not in the denominator, if we go any lower than that, if we put in 0.9, then it's going to be a negative fraction. That's going to give us a negative under a radical. So this is the domain for this problem.